So this is the next in my series on integration. If you've just landed on this video, I strongly recommend that you watch, number one, my series on differentiation. It's very important, otherwise you won't understand what's going on here. And also, this is the second video in my series on integration. So if you haven't watched my previous one on basic principles and integrating basic functions, you do need to do that as well. This video, we're going to be looking at integrating harder types of functions, so using your index laws to manipulate the functions such that they are written in a form that you actually know how to integrate them. So a general structure of this video, we're just going to rattle through a load of different functions. So to begin with, let's take a look at this one. So very similar to the examples we looked at in my differentiation video, where we're looking at harder types of functions. So we're integrating 1 over x to the 5 minus 3, that's the cubed root of x. So here you need to write these in a form such that I'm just have a single power on x, i.e. x squared, x to the minus 5, x to the half, etc. So you need to apply your index laws, which are up in the corner of the screen now, to rewrite each of these terms such that they are expressed with a single power on x. So this first term here, to remember, multiple terms, in this case one subtracted from the other. I'm just going to integrate these term by term. But first of all, I need to rewrite my integral. So rewriting this first term, 1 over x to the 5, you know that 1 over means that I'm going to have a negative power on my x. What's that negative power going to be? Well, I've got 5 here as the power on my x on the bottom of this fraction, so it's going to be minus 5. Similarly, if there was a 4 here, that would be a 4. If there was a half here, that would be a half there. Okay, and then similarly, second term here, I've got my cube root on x, so it's going to be a fractional power in this case. Fractional power in this case, my power is going to be third. Okay, so if I had square root, i.e. there was a 2 up here, then it would be a 2 on the bottom here. If I was looking at the fifth root on x, then this would be a 5 here. And then just a note on this number 1 here, if I had this, so we will go through these in subsequent examples, then I would have still a 3 on the bottom because we're still looking at our cube root, but this whole thing is squared, so rather than having a 1 up there, I would now have a 2. Okay, and then just working out that integral, so I've got x to the minus 5. This is now in the form such that we know how to integrate it, so we're just going to apply a rule. So you notice each of these are expressed with a single power on our x. What I'm going to do is increase this minus 5 by 1, gives me minus 4 up there, divide through by my new power. Similarly here, x, raise this power by 1, gives me 4 over 3, dividing through by 4 over 3 there, and don't forget your plus c. So this is going to be, just tidying this up, it's just going to be a negative. Fine for me to leave it like this. This one, don't like to have fractions within fractions. How can I change that? Well, rather than having a 4 over 3 on the bottom, I can change that to have a 3 over 4 out the front of the fraction. And then plus c stays the same there. Go through another example where we are simply applying our index laws. Again, to look at this one, so 3 over x to the 4 minus 1 over root x. Integrating this with respect to x. Let me just make sure I've used my correct notation here. So sorry, I did forget my dx up here previously. By the magic of video, that won't happen in the final edit. So again, just applying my index laws here. So looking at this first term here, 3 over x to the 4. So you compare this to what we had previously. So here we had 1 over x to the 5, sorry, and that came out as x to the minus 5. So you notice no number here on the top. Now we do have a number, so this is a reciprocal function, but we've got a number on the top here. How does it change things? Well, it's going to be negative power. See, that number here is going to be 4 because I've got a 4 there. How does this 3 change things? Now, rather than just having 1 over x to 4, I've got 3 lots of that, so I'm just going to stick a 3 in front there. And the second term, got 1 over, so again it's going to be a negative power on my x. What's that negative power going to be? Well, here I had a 4, so it's going to be 4 up here. Just notice here, what is my power on x? Square root means to the power half, so in this case it's going to be a half there. Integrating this with respect to x, and then just applying our rules, we have 3x to the minus 3 all over minus 3 minus x, raise this one by 1, so that minus a half now becomes positive a half, dividing through by half. 3 cancels with this 3, so essentially I'm just left with a negative x to minus 3. Again, we don't like fractions within fractions, so rather than having this fraction on the bottom, I can flip it over, bring it out to the front, minus 2 over 1, or just 2x to the half dx. And that would be our final answers for that one. So just as I'm rattling through these examples, obviously if we're going through these using my notes online, are very, very good, and we're going through individual exercises, then they build up sequentially. So now that you look at these first two, when we're simply applying our index laws, it's fairly easy to track exactly when the exercise you can complete up to. So if you want to stop watching this video now, come back to it later on, go through the first, I'm not sure exactly how many it is, probably 8 to 10 questions of my exercise, then do that. But we're going to move on to expressions involving brackets that you need to expand. So here we're going to expand this. Okay, and I could stick another set of brackets around these for completeness. So I'm integrating x times by this whole thing here. So I've got one term inside my brackets, 2 terms inside this inner set of brackets. You know you can just expand these out. So first of all, essentially I'm going to multiply this one term here by my 2 terms inside the brackets. What's it going to leave me? Well, I've got x times by x to begin with, x squared plus x times by this whole fraction here. I'm just going to write it like this to begin with, 3x over x cubed, and then I can tidy it up in my next step. So tidying this up now, you know, in order for us to be able to integrate this, this needs to be written as a single power on x. So this first one is fine. I know how to integrate that. This second one here, well, let's do this to begin with. So that x cancels with this. So essentially I've got 3 over x squared, and if you follow our rules from the last example we looked at, you know it's going to be negative power. That power is going to be a 2 because I have a 2 here, and I've essentially got 3 lots of it, so 3 there. Now I can actually perform my integration. So x cubed over 3. Now just raising this power by 1, dividing through by my new power. And similarly here, I have 3x to the minus 1, so that minus 2 becomes a minus 1, divided by my new power, plus c, of course. So now just tidying up, made my first mistake there. We've got 3 divided by minus 1, which is minus 3, so that positive term now becomes negative. Minus 3x to the minus 1 plus c. And that's your final answer for this integral here. Look at one more where we are expanding brackets. So basically, one thing that you need to appreciate is that if you have an expression where you can expand the brackets, then it's fairly safe to assume that you are going to expand the brackets in order to perform the integral or perform the integration. So in this case, let's write this out in full. So essentially I have root x minus 3 times by root x minus 3. Okay, and I'm integrating this all with respect to dx. So what I'm going to do is expand these sets of brackets in my square brackets, which gives me root x. So this one multiplied by this one, minus, so this one multiplied by this one now, minus 3 root x. Now looking at the second term in the first brackets, minus 3 times by this one, root x, times by, minus 3 times by minus 3 gives me plus 9 respect to x. Now is this in the form that allows me to integrate term by term? No, it's not. I don't have single powers on my x just yet. So carry on working on this. Root x times by root x gives me x, minus 3 root x, minus 3 root x. So just collecting like terms here, minus 6 root x, plus 9. So we're nearly there. Just need to change this middle term now. So this term we know how to integrate, this term we know how to integrate. This term we need to change it before we perform the integration. What am I going to change it into? Well, I've got root x, so it's going to be x to the half. How many lots of that do I have? I've got 6. Now I can integrate that. So integrating my linear term, you know it becomes a quadratic term. So that 1 up there becomes a 2, divided through by 2, minus 6x to the 3 over 2, divided by 3 over 2, plus 9x, so constant terms become linear terms, plus c, and then just changing this second term there such that it's written in nice conventional form. So I've got minus, just remember, the denominator of this fraction, or sorry, the numerator of the denominator, if you like, i.e. this number, will stay the denominator. If I bring it out the front, I'm just going to multiply this one by this one to give me 12. X to the 3 over 2 plus 9x plus c. And lastly, you can see that you can cancel that coefficient there. Minus 4x to the 3 over 2 plus 9x plus c. So those are our examples where we are integrating expressions which involve expanding brackets. The last one we're going to look at is the case where you have a fraction actually in your integral. So we are going to integrate this 5x cubed plus 7x all over x cubed dx. Okay, I'm just going to stick this in brackets just as a reminder that really you should be, for this one it's not that important. I'm not going to go into the ins and outs of it, but generally speaking, if you're using your integral notation, your original function should really be written in brackets. It's just generally good practice. So when I have something like this, you notice I've got a fraction, I've got a numerator and I've got a denominator, you can actually split up this fraction here into two separate fractions. But to begin with, if you look on the top here, that looks like something that you could expand, so that's what we're going to do. Integral of, so just expanding the top, 5x cubed plus, that's this times by this, now this times by this. 5 times by plus 7x gives me plus 35x all over x cubed, integrating with respect to x. Now I can split up this fraction here. So I have 5x cubed over x cubed plus 35x over x cubed. So just splitting up my fraction here such that I have, if you like, half of this numerator over the denominator, which gives me this, and then the second half of my numerator over the denominator, which gives me this one here. Okay, just simplifying what we can on this line here. So this cancels with this, which just leaves me with 5. This cancels with this, so I've got a 2 up there, so plus 35. No, I'll do a bit more work. So 35 over x squared. How can I rewrite this such that I just have a single power on my x? Well, x squared, you know it's going to be a negative power because I have a reciprocal function. My x is on the bottom. It's going to be a negative power. What's that power going to be? It's going to be a 2. How many lots of this do I have? I have 35 of them. So whatever my number is on top here is a number that's going to go in the front here, respect to x. And now this is in the form that I can integrate it. So integrating term by term, my constant becomes a linear term. Now this one, 35x to minus 1 divided by minus 1 plus c. And then just tidying this one up, 5x minus 35x to minus 1 plus c. That'll be my final answer for this one. So when you have a situation like this, and it's exactly the same as when you were differentiating, when you have something like this, all you need to do is split up your fraction into 2 separate fractions if you have this. And obviously if you had one more term up there, you could split this up into 3 fractions. But once you've done that, then a little bit more work, so just applying your index laws, and it should be in a form that allows you to integrate term by term. Thanks very much for watching, and don't forget to subscribe for more tutoring videos. Remember that full notes and other resources are available on my tutoring website at idktuition.com. And if you'd like me to cover anything in particular, please leave me a message in the comments below or on Twitter at TomDavies32.